In this video, we're going to have a look at how we can do part B of the original highways assignment. So going down in part A, what you had been tasked to do was to find the distances between the various waypoints on the map. And then in part B, it's asking you to find the equations of the lines that will connect all of the points together. Now, what does that mean? Well, if I bring up the Desmos program here, what you would have done by now is, I'll set the transparency lower. What you'll have done by now is you would have plotted all of your points on the map, or all of your waypoints. So let's get rid of the map. And what that would look like is something like this. Now, this isn't particularly intuitive just yet because they're just points on the map, but rather the objective is we need to map out the roadways. So what you're going to find is that the solution should look something like this. Now, I'm not going to show you the equations or the points for that matter because remember, that's your job in the assignment. But what I will do is I'll show you how to do this first line here. So the line linking Carnarvon Gorge to Roma. So to do this, we're going to use the same method that we've been using in chapter 6 in class. So over in this OneNote document here, I've simply listed down the 2 points that I want to get a line to go through. So the way in which we're going to calculate the line is, firstly, we need to calculate m. M being the gradient. And if we think back to class, we know that the gradient can be calculated as the rise over the run, and that can be written as, more technically, y2 take y1 all over x2 take x1. Now, to use this formula, we need to have the points themselves delegated as point 1 and 2. For convention's sake, I'll just say the first point will contain x1 and y1, and then the second point will be x2, y2. Now, using these 2 points here, all we need to do is substitute the values of x1, y1, x2, y2 into this equation here. So y2 is going to be 1, and then x2 is negative 1.56. Now, throwing all of these in the calculator and crunching the values for us, we discover that the value of m, or the gradient, is equal to minus 3. So that's task 1 done. Now, our second task is we have to start building the equation, and then we find we need to calculate the value of c. So calculate the y-intercept, or c. Now, recall back, the equation of a line can be written as y equals mx plus c, and therefore this can be arranged or rearranged in terms of c. So c becomes the subject. You can rearrange it to be y, or c equals y take mx. So I simply grab this and I move it to the other side, so it becomes a negative. Alright, now next step is we need to sub in the values of either x1, y1 or x2, y2. It doesn't really matter because this line itself is going to pass through 2 points, or both of these points. We can use either to get the value. So in this case, let's go let m equal minus 3, and then we'll say let x, y equal, we'll go x1, y1. Actually, no, we'll go x2, y2 because it looks a little bit nicer to deal with. Negative 1.5, and so 1 plus 1.5 times 3 is 4.5. It's a negative, so it's going to come out as a, so we'll get rid of this positive here. Just don't need that. And 1 take 4.5, well, that's going to be minus 3.5, like so. So therefore, we know the value of m, we know the value of c, and then we just need to put it all together. So constructing the y equals mx plus c, what we're going to find is that our y value is equal to minus 3x 5. Now, to verify this solution, what we're going to do is we're going to substitute this back into Desmos. So we'll turn those off and we'll say y equals mx plus c. And it's going to queue us to add these in, but this time we're not going to do it. We'll go minus 3 and then take 3.5. And lo and behold, we now have this line that passes through both of these points here. Now, the next part of the assignment is a little bit tricky, and it's something that it's not really part of the Year 9, or for that matter, the Year 10 Australian curriculum. But if you're choosing to do mathematical methods in, say, Year 11, then it's a concept that you will see. And what it's called is, it's called the domain. It's a manner in which we can describe how much of this particular line we actually want to plot. Now, in this case, we want to plot the line between, or graph the line, I should say, between these 2 points here. So what I'm going to do is I'm going to set a domain that specifies that the line goes only between negative 2.6 and negative 1.5. So to do that, I'm going to get these curly braces. Then I'm going to do these less than or equal to symbols. In the very middle, I'm going to type x. And then on the far left, I'm going to type the smaller of the two values here. So negative, or the more negative of the two values, I should say. So minus 2.6 and negative 1.5. Well, the most negative one is negative 2.6, and the other one is negative 1.5. And behold, what we have is a line that passes, or I should say a line that connects these two dots together. So what we've seen is we've seen a method of calculating a line that connects these two dots, and how we do it using pen and paper. Alright, so now the pen and paper method is out of the way, I'm going to show you how to do it using Desmos directly. But remember, when you're doing these, you still will have to show the calculations on pen and paper. But if you want to verify it with Desmos, then I'll show you the method. Now, let's get rid of this, even though it's a lot of hard work, and we'll write y equals mx plus c. Then Desmos will cue us for adding sliders for m and c. We say, yep, put them in. Now for m, I'm going to go 1 over 1, and then I'm going to look at the 2 points here. Remember that we're going to have y2 take y1, and then x2 take x1. What we need to do is replace these values here directly with the values here and here. So y2 is going to be 1, y1 will be 4.3, x2 is negative 1.5, and then negative 2.6. Perfect. And what we've got is a line that looks to be okay. Now if I move this slider down, we'll find that will indeed equal negative 3.5, but I'll show you how to do it by putting the values in. So we expect it to be y take mx. So what this means is we need to get either a value of y and a value of x and throw it in there. So in this case, we'll take the value 1 and we'll replace x with, we'll replace y with 1. Then we'll grab the corresponding x value here, we'll hit times, and then throw it in, and boom. What we find is Desmos does the calculations for us. So here and here. One thing to pay attention to is this is a decimal. If you want to represent it as a fraction, you can click on this button. So minus 7 over 2 or negative 3.5. If you find that the value for C or even the value for M is a non-rational number, as in it's a decimal that cannot be simplified neatly, then you need to click on this to get the exact form, because we always want exact form. Alright, moving on, we want to clip this again, so we'll put in the domain. Oops. So I'm going to grab the two values of x, so it will be negative 2.6, always the very least one, or the smallest ones first, and then negative 1.5, and we are done. So what you'll need to do is this exact process here for every point. And remember, you need to show your working out as well, so I can see that you'll be okay when you come to encounter this in, say, a test or the future.